So now I worked the last couple of problems in the chapter. So the next one is number 70. It says the average lifetime of isolated neutrons measured at rest relative to the lab is 920 seconds. What's the average lifetime of neutrons traveling at 80% the speed of light? So we know that in the rest frame, their life is 920 seconds. Okay? And we also know that now they're traveling at 80% the speed of light, which we can write as 0.8 times c. Remember that c is the speed of light. So the first thing that we need to do is figure out what the gamma factor is. Remember again that this is how we write it. 1 minus v over c squared. And our v is 0.8 c. So we just plug that in. The c's cancel, giving you this. Okay? When you go ahead and solve this out, you'll end up getting, let me write it down here so you can see, you'll get 1 over 0.6. When you just square the 0.8, take 1 minus that square root, you get 0.6. 1 divided by 0.6 is 1.67. So that's our gamma factor. Now we know that we want the time in the moving frame. To get that, you take this gamma factor and you multiply it by the time in the when it was still. Okay? So that would give us 1.67 times 920 seconds, which ends up being 1,533 seconds. Okay? And one way you may be wondering, like, how do I know whether to divide this gamma, divide the t of naught and by gamma or multiply it? How do I know which way to do it? Because the book kind of shows both. One way that you can always check yourself and the way to think about it is remember that when it's moving, the time is going to be lengthened, and so you would expect to have a larger answer than what it was when it was still. Okay, and so with length, which we'll do in the next one, you'll see that when you're moving, the length shrinks, and so that's what you would expect. So let's go ahead and do the next one. It's number 74. And it tells us a rocket ship is 80 meters long. When measured at rest, what is its length measured by an observer who sees the rocket ship moving past at 99% the speed of light? So again, the first thing you always do, figure out what gamma is. Here our v is 0.99 c. So again, you can just plug that in, so you get 1 minus 0.99 c over c squared. C's cancel. When you go ahead and solve all that, you get a gamma of 7.09. Okay? Then we know that the L moving, which is the length when it moves, is equal to the length when it's still, divided by gamma. Now here I know that it's divided by because I know it's going to end up being smaller. The length has to be smaller when it's moving. And so if we take 80 divided by 7.09, you end up getting an answer of 11.3 meters. That's how long it would appear. So you can see how much it contracts. It goes from being 80 meters long to being 11.3 meters long when you're traveling at 99% the speed of light. So those are all the answers. You did do one last problem, 82. I actually decided, I talked to a couple of people whenever they were doing their homework, and I think that problem was actually probably too difficult for a lot of people. So that was my fault for assigning it, and I ended up not putting anything like that on the quiz. So you don't have to worry about the whole energy aspect of this chapter. You can skip over that and more focus on the other sections. So if anybody has any questions still, feel free to ask me, and good luck on the quiz. I appreciate all your hard work. Thanks.